Welcome to the viewers. Today we discuss the topics and with the help of a table in a finite group. Suppose S, if S be the finite group containing the element 1 omega and omega square, then we have to prove S dot with respect to operation, binary operation dot is forms a group. How to form this group? We at first, to prove it, we at first construct a table 1 omega omega square and here omega omega square. Now suppose we are multiplying this 1 dot 1, clearly it will be 1 dot omega omega and 1 dot omega square is equal to omega square. Here also omega dot 1 equals to omega square and omega cube equals to 1. That's how. Just one point to be noted. Here omega is cube root of unity. Omega is a cube root of unity. That's why omega cube equals to 1. Here also omega square, omega cube equals to 1 and omega to the power 4. That is omega cube into omega. So it will be 1 into omega, that will be omega. So here in this way we construct the table. Now at first check the property of the groups. First property, if we consider it 1 dot 1 1 and this 1 is lying on the table, 1 dot omega, that will be omega, also omega there. In this way every element is on the table with respect to the binary operation dot, and omega dot 1 simply, that will also omega in the table, omega dot omega, that will omega square also in the table, and omega dot omega square, that will be omega cube. Since omega is a cube root of unity, so it will be 1. In this way we find that every element with respect to the binary operation is on the same set. That means here on the same set. That's why S is closure under dot. So closure property holds. Next, if we consider one dot omega square, it will be 1 dot omega cube, so it will be 1 dot 1 equals to 1. Similarly 1 dot omega square, that will be omega dot omega square, it will be omega cube, so it will be also 1. So we can say omega dot. So associative property holds. If we take any pair of element that also lies in the same table, and it is also clear that associative property is inherited property in any group, so it is an inherited property, so clearly, and we can also say from the property of dot, like as this type of elements, we can take any type of such element, we getting the same results. So associative property holds. Next, 1 belongs to S. Here also it's to be noted that for every elements belongs to the set, that is 1 omega square, so all are belong to set S. Here also the same things. Here every element like 1 belongs to S, omega belongs to X, so every elements belongs to the same set. Belongs to set S. 1 belongs to S, and it's clear 1 dot omega is equal to omega dot 1 equals to omega. So 1 is the identity element. Similarly, if we taking any kind of pair dot multiplication with respect to multiplication, if we take any types of elements like omega square 1 whatever may be, we get the same element, that's called the same element. So it's 1 is called identity. So 1 is identity element in S. Next, and it's clear, when associative property holds, it's called semi group, and identity element holds, it's called monoid. Next, for any elements, if we take omega inverse, that will be 1 by omega cube equals to 1, that will be omega square, also belongs to set S. So every element has its own inverse, and it is also clear from the table, that is omega inverse. Since omega square into omega equals to 1, so omega and omega in both are inverse terms, and here also omega square equals to 1. So every element has its own inverse. It is also we take from the table. Finally, we find that the group is symmetry about the principal diagonal, so it is abelian group. And also we noticed here that commutative law holds, since from the table the matrix is symmetric about principal diagonal. So S dot is abelian group. It is extra additive property, and here after the inverse formation we called S dot is a group, and more than that extra property, and from the principal diagonal matrix is symmetric about principal diagonal, so it's form an abelian group. Now today we end our classes. Thank you.